So here we have definite integral between the limit 0 and pi of the expression x tan x upon sec x plus tan x with respect to the variable x. As I told you earlier also, this presence of x, this x can be eliminated because everywhere we have a trigonometric function and this x independently it is an algebraic function. So here, as usual, we make use of the sixth property according to which the variable x present in the integrand will be replaced by the upper limit minus the variable. So in place of x, I'll be writing pi minus x here, 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 and here. I arrive at this particular step. After that, I just need to justify what do we write for tan of pi minus of x. It is minus tan x, same minus I've written here, tan x here. Secant pi minus x is minus of secant of x, tan pi minus x is minus tan x. This negative sign can be taken as common, can be cancelled out, neutralized. We get pi minus x tan x upon sec x plus tan x. Is these two negative signs, they have been neutralized. So we arrive at this. I take the given quotient as the first equation and this modified form as the second equation. And the left hand sides being identical as per the sixth property, which is definite integral within the limit 0 to a fx dx is equal to 0 to a f of a minus x dx, definite integral. So we simply add both these equations. The left hand sides will be added together to give us twice of I. Right hand sides as usual being under identical limits of integration. So integrands, that means the functions that we are to integrate here and here, will be summed up under a single integral sign within the common limits. So we have 0 to pi here, 0 to pi here as well. So it remains 0 to pi here. So x tan x upon sec x plus tan x added with pi minus x tan x upon sec x plus tan x. Since the denominators are identical, I'm writing this step directly. So denominator identical, common denominator will be there and the numerators will simply be added. We have x tan x and pi minus x tan x. From there I've taken tan x is common, so it is x plus pi minus x, which is visible here. X and minus x gets cancelled. This tan x in product, it remains outside. So this constant pi, can bring it out here. So they were leaving us with tan x in the numerator and sec x plus tan x in the denominator. Now at this step we have to do two things. Note them very, very carefully. Very first thing is to apply the eighth property according to which the upper limit can be reduced to its half. So we've done that property earlier also. So by using the eighth property, 0 to 2a, definite integral 0 to 2a can be written as 2 times of 0 to a if f2a minus x is same as fx. In place of 2a we have pi. So if I write pi minus x in place of x in this integrand, so it comes out to be the same after cancellation of negative sign we have seen earlier also. So we get tan x upon sec x plus tan x by x. That's why we can pick 2 as common from here. And you can see here in blue I have written 2 here. And thereby reducing the upper limit of integration to its half, it becomes pi by 2. So, and this pi we have already taken outside. So I'm left with tan x upon sec x plus tan x. So I have reduced the upper limit of integration to its half, but thereby taking 2 outside. The second thing that we have to do is to write tan as sine by cos, this sec as 1 by cos and tan as sine by cos. Take the LCM of denominator, it will come out to be cos and it will cancel with the cos existing in the denominator when we write tan x as sine x upon cos x. So on modification we'll be left with sine x in the numerator and 1 plus sine x in the denominator. So after that, if we just like come to this step, so looking at the denominator 1 plus sine x, I'll try to match the numerator with the denominator. That can be done simply by adding 1, but there is no means 1 already existing in the numerator. So if I add 1, I need to compensate for that. So that can be done by subtracting 1. So I have added and subtracted 1 here, as you can see. Then I will prefer splitting this into two parts. I'll be writing 1 plus sin x upon 1 plus sin x minus 1 upon 1 plus sin x. This 1 plus sin x being the common denominator. So we form these two integrals from here. 1 plus sin x divided by 1 plus sin x makes it 1, that I've written over here. 1 upon 1 plus sin x we prefer writing here separately. And here we can cancel the limit. You can observe this 2 and 2 will be cancelled out from both the sides, thereby leaving us with I. I is equal to pi here. Upper limit has been reduced to pi by 2 earlier also. So we are left with 1 over here. In place of sign, I'll prefer writing 2 tan x by 2 upon 1 plus tan square x by 2. This is a particular technique of indefinite integral. You should keep in mind that whenever we have sine or cos containing terms and they are in addition or subtraction, or any one of them with another constant, then we prefer splitting or writing sin x in terms of half angle formula of tan. So sin x has to be written as 2 tan x by 2 upon 1 plus tan square x by 2. Go for LCM here. This is 1 here. So this we get 1 plus tan square x by 2 is the LCM, and shifted to the numerator for 1 plus tan square x by 2. We can write secant square x by 2 as you can see here. And this 1 plus tan square x by 2 will be multiplied with 1. So we get 1 plus tan square x by 2 plus 2 tan x by 2, which is in fact the square of tan x by 2 plus 1. Right? So I've written tan x by 2 plus 1 whole square here. Now here, as you can observe for this portion, secant square x by 2 is available in the numerator, and it is the derivative of tan x by 2, of course with the common factor of 2 also that has to be adjusted. So we go for the substitution. Tan x by 2 is t, then secant square x by 2 with dx will be converted to 2 dt. So secant square x by 2 with dx will be converted to twice I've written outside, and this entire thing is dt. Tan x by 2 I've taken as t. With this conversion from x to t, I have to modify the limits of integration also. So I take x is equal to 0 here. Tan of 0 makes it 0, so lower limit is 0. I take x as pi by 2, place it here. So pi upon 2 divided by 2 makes it pi by 4. Tan pi by 4 is 1, so upper limit comes out as 1. Now watch it carefully. Minus 1 upon t plus 1 whole square is the derivative of 1 upon 1 plus t, or 1 upon t plus 1. So integration of minus 1 upon t plus 1 whole square is minus. So this minus sign is being converted to plus 1 upon t plus 1. And limits of integration remaining the same, 0 to 1. You can replace t by 1 in the first portion, and in the second portion t by 0. So we get pi here as it is, pi by 2 here, this sign is plus sign. If I replace t by 1, I get 1 plus 1, 2. 2 divided by 2 makes it 1, so I placed 1 over here. From there, I have to subtract the value of same expression for t is equal to 0. When I write t is equal to 0, this expression reduces to 2. 1 minus 2 makes it minus 1, so I'm left with pi upon 2 minus 1 inside the bracket, pi outside. On simplification, this becomes pi minus 2 divided by 2. I can write this 2 under the first pi here. So pi upon 2 in product with pi minus 2 comes out as my final answer. This is a very, very important sum. Over to question number 9.